Everyone again, welcome to our machine learning tips. So in the previous lesson, we did look at decision trees, and I did mention that decision trees, they are a good foundation from key techniques like random forest and the extreme gradient boosting algorithms. Random forest and XGBoost, they are used a lot in real-world applications because I did mention earlier that decision trees are very easy to overfit. So today we will be starting with the first concept from which builds from decision trees, which we call it what random forest. Random forest, as we call it, is an assembler learning method based on what the decision tree. Assembler because it's just like a combination of different decision trees that can be used both for regression and classification problems. So the motivation, why are we really interested in random forest? Decision trees are simple, but they are very prone to overfitting. And then we need a method that can reduce variance and improve upon what generalization. I did mention earlier that before we can use decision trees and make it generalize on unseen data, we need to prune those trees pretty well. And when the dimension of the data becomes so large, decision trees can easily overfit. So random forest is just a good technique. We're reducing variance here because we are using a combination of trees built on a random subset of the data. They can easily reduce variance because for classification problems, they only look at those trees that have the majority voting. Take, for example, if it was the breast cancer prediction, the trees that says that maybe a tumor type is malignant, that combination, that majority vote, the model will predict that that tumor is malignant. Another key thing we have to note here is that these random forests, they are a combination of many decision trees, which can can reduce variance as much as possible. So what is random forest? Random forest is an assembly of decision trees, and then we can use it, as I did mention, for um, both classification and regression problems because this is supervised learning method. For classification problems, the final prediction is what we call the majority voting. As I did mention, if you have like 1,000 trees and then maybe 800 of those trees says that the tumor would be malignant, and then the overall prediction will be what will go to the malignant class. And then for regression problems, it will look at the average of those outputs from those trees. So if it was like you're predicting house prices, it will look at the prediction for, if you like 100 trees, it will combine the prediction for all those 100 trees and then take the average from those 100 trees, which makes it very easy because it can reduce variance as much as possible. But remember, one of the key concepts that we looked at in machine learning is what bias and variance. So the key concept here is that what is random forest? Random forest, we call it is a bagging approach, which it can also be called bootstrap aggregation, which simply means here that each tree is trained on what a random sample from that data, which is from the training data with what with the replacement. So also when we pick that random sample from that, it also goes with what a random future selection. So each split considers only a random subset of what futures based on what based on the random subset that was picked for each training for each of those the training for training each of those trees. And then because we are picking a random sample and which include a random subset of futures, it is easy to promote what diversity among those trees. What I mean here by diversity is that if one of those trees is having a lot of like high variance and another one has a lower variance, since we are combining all those trees, there is a tendency that we will reduce the overall variance, which is what we really look on in most machine learning models. So why random forest works is because we have decision trees. Most decision trees will lead to what high variance, which are unstable. But if we look at averaging many of those decision trees, it can reduce what? It can reduce variance. And then also each of those trees are built on a random subset of data from the training and what futures, which can reduce what correlation. It can lead to less correlation among those futures. Remember when we started doing linear regression, I did mention something like what the key concept of what multicollinearity, which occurs within those futures. If you are using random forest, you do not need to bother much about that concept of what multicollinearity that causes a lot of problems for linear regression models. Another concept that we have to note here for why random forest work is that it's better for generalization compared to what single trees, because if you train like 100 trees, it is easier since you are combining those trees to be able to generalize on unseen data compared to a single tree. So the important hyperparameters that we'll see when we are doing a lab session in random forest is what we call what the n underscore estimators, which is what the number of trees that we are going to consider in that forest. Also, we'll look at the maximum depth of those for each of those trees, and then we also need to consider the number of features to be considered for each split. By default, it takes the square root of all the features in the data set when it's doing that random selection. But we can change that future. We can decide to take maybe just 10%, we can take 20% to when we are doing that training, as well as we can also look at the minimum sample splits, at minimum sample leaves that controls what they will split. We are going to see more of this when we are doing the lab sessions. So the advantage of random forest is that it can lead to higher accuracy than single trees, which are the decision trees. It can handle large and high dimensional data set. It is very robust to noise and what an outlier. Robust to noise and outlier because we are using, training multiple trees and then looking at either for classification problems, we are looking at the majority voting, as well as for regression problems is the average of all those trees. In that case, it will be very easy to eliminate what noise and what an outliers. It can also provide what we call what future importance across scores, which we are going to see what this future importance is when we are doing those labs. So the limitation that we are going to have with random forest is that it is less interpretable than the single decision trees. It is more computationally expensive and still might overfit if there is not enough randomness or what constraint. So the applications where we find this, most of this model is used a lot in credit risk modeling. We can use it also in medical diagnosis and disease prediction. We use it in fraud detection, stock market and financial forecasting, as well as in what recommender systems. So in summary, today we looked at random forest, which is an ensemble of decision trees. And then we also looked at how these models are trained, which is like just picking a random subset from the training data, as including random features. And then we are training multiple trees. Since we are training multiple trees, a combination of those trees can reduce overfitting and improve accuracy. And this is also a key concept to advanced ensemble techniques like the gradient boosting algorithms. So for random forest, we use it especially when we know there is a lot of high variance in whatever model we are trying to build, but it doesn't actually reduce bias as compared to assembler method like the gradient boosting algorithms. Those are some of the disadvantages of the random forest. Guys, keep following me for more of these tips, both on YouTube and Facebook. And as I did promise, you are going to learn more see how these models work more in real world applications. Thank you so much.